Good morning, Manandal Prasan here. Today we are going to discuss about the case study on FE related case study. In our FE subject, we have discussed the how to solve the one-dimensional and two-dimensional problems by using the FEA, and fourth unit consists of heat transfer. How the heat transfer will occur during the either designing either analysis times. Okay. Today we have to discuss the case study on finite element analysis of internal shaft bearing. Okay, how the internal shaft bearings are working, how the loads are withstand, and how the stress and strains are distributed during the loading conditions. These are we have to find out by using the finite element analysis procedure. Okay, shall we discuss the abstract of this case study? First, the internal shaft bearing is popular for higher specific load carrying capacity and preventing the misalignment defects and eliminating the risk of undesirable distortions of the bearings rather than the conventional one. These are all the advantages of internal shaft bearings usage. And internal shaft bearing is used to reduce the rotational friction and support radial and axial load friction in the bearings, which cause an increase of temperature and stress inside the bearings. It can be eliminate the stress and the internal heat generation inside the bearings. Okay, if the heat produced cannot be adequately removed from the bearing, the temperature might exceed a certain limit, and as a result, the bearing would fail. If the temperature is maintained in normalizing temperature means without any damages are occurred. If the temperature will be increased, means automatically the bearing failure will be occurred. To analyze the heat flow, temperature distribution, and stresses in the bearing system, a typical integral shaft bearing and its environment has been modeled. By using any one of the CAD packages, we have to design the both 2D and 3D model of the heat internal shaft bearings. After that, we have to analyze using the famous finite element tool analysis. In this study, we investigate the structure and thermal characteristics of performance of integral shaft bearing to analyze temperature distribution and internal elongation due to the friction, also its effect on the bearing clearance. These are all the some of the keywords we have to important keywords are used in this case study, like we are using internal shaft bearing, and modeling purpose we have to use the CAD packages, and meshing structure and thermal analysis are made by using the ANSYS software. Okay, this is the introduction. This is the one of the roller deep type of roller ball bearings. Okay, objective of this research is to design of integral shaft bearing for water pump. We have to design the internal shaft bearing for the water pump applications, and modeling and assembly of bearing components from 2D diagrams to 3D model. We have to make the 3D model diagrams by using any one of the CAD packages, and stress analysis and temperature distribution for the internal shaft bearing by using the FEs like ANSYS, and thermal elongation of the components in internal shaft bearing at different temperature and its effects of bearing clearance. Okay, these are all the main objective of this case study or research paper. Okay, then these are all the material allowable stress considering the internal bearings. Okay, these are all the some specification of material allowable stress already we have to given. These are all the, some of the geometrical model while designing the internal shaft bearings, like steel diameter, shaft diameter, and these are all the. Then these are the part geometry. You have to complete the part geometry created in CAD environment. We are using the Pro E 5.0, or we have to use either Solid Edge and some other CAD softwares are used to make the 3D model of the bearing, internal shaft bearings. And after completion of design process, the CAD design is imported to the ANSYS software. Then first step of the finite element analysis is to discretization or meshing. Okay, discretization means you have to convert, you have to divide the structure are either product into convenient number of elements, that is called discretization or meshing. In this analysis, mesh generation is auto mesh generation. The element size is 20. Okay, we have to mesh this internal the SAP theory. After that, we have to apply the boundary conditions, loading and boundary conditions. We have to apply the both boundary and loading conditions in both the radial and axial directions. Okay, this is the loading condition. After that, we have to find out the where the maximum load will be acquired. We have to find out the maximum load and thermal conditions. This is the thermal. After running of the solution above model, we get the different values solutions such as maximum principal stress, equivalent stresses. These are all the maximum principal stresses diagrams. The red color indicates the maximum stress distribution zone, and blue color indicates the minimum stress distribution zone. Okay, same again. These are all the loading conditions. And after analysis, we have to receive these diagrams. This is the equal stress for rollers. Inside the bearing, we have to add the sum of the rollers. That is called roller bearings. So, equivalent stress for rollers also we have to calculate it. And directional deformation for the rollers also we have to calculate it. And these are all the balls, equivalent stress for the balls. We have to make the analytical calculations by using the normal theoretical formulas. These are all the analytical calculations made by using the